This diagram shows two boxes of roughly the same volume. We can tell the box on the right has more weight, or in other words, more mass. It could be because the box has more particles in the same amount of volume, or it could be that these particles have more mass. All we know is that the material on the right-hand side, the box is made out of something that's more dense. Because the density is the mass per unit volume, as given by this equation here, where m is the mass in kilograms, v is volume in meters cubed. So density, given this Greek symbol here, rho, is measured in kilograms per meters cubed. Here's a table showing the density of different materials. A really useful one to learn is water, which is 1,000 kilograms per meters cubed. So that means if I had a meter by a meter by a meter box with water in it, it would have a mass of 1,000 kilograms. Okay, you can see some gases here, which have very low density, and you can see some metals, which have very high density, for example, lead. Okay, you should know how to calculate the density of different shapes. So on the top left here, we've got a cuboid, and you can calculate the volume by doing A times B and C. Then we've got a sphere here, which has a volume of 4/3 pi times the radius cubed. And if you have diameter, you just have to divide the diameter by 2 before cubing it. And then you've got a cylinder here. So first, you've got to work out the area of the circle using pi r squared as the cross-section area, and then multiply by the length. So you get pi r squared times the length. And to be honest, you can use it for any shape as long as you work out the cross-section area first. So in this case, the trapezium, and then you just multiply by length. You can work out the volume of any shape like this. Okay, in this example, we have a ball which has a radius of 20 centimeters and a mass of 0.80 kilogram. Calculate the density of the ball. The density is mass per unit volume, and the volume in this case is the sphere, so I'm going to write 4/3 pi r cubed. Okay, so firstly, before I do the r cubed, I'm going to have to turn the radius into centimeters, so divide it by 100. That gives me 0.2. So then cube it, then 4/3 pi. Okay, that gives me a volume of 0.03351. And then I can take the mass, which is 0.8 kilograms, and divide it by the volume, give me a density of 23.9 kilograms per meters cubed. Okay, the density of copper is 8.9 grams per centimeters cubed. Convert the units to kilograms per meters cubed. Okay, so 8.9 grams per centimeter cubed basically means 8.9 grams for every centimeter cubed. I'm going to turn the grams into kilograms first by dividing it by 1,000 to the 3. So that gives me 0.0089 kilograms. Then I'm going to convert the centimeters cubed into meters cubed. So to do that, I'm going to turn centimeters into meters first. Okay, so I know I need to divide by 100 there. Okay, so 100 centimeters makes up a meter there. But for a centimeters cubed, I need to divide it by 100 for each centimeter. So there's a cube there, so that means I divide by 100 cubed. Okay, so that gives me a very small volume in meters cubed. I'm going to put that back into the equation there, and that simplifies to 8,900 kilograms per meters cubed. The scaffolding pole has an external diameter of 40 millimeters and an internal diameter of 32 millimeters. It's made out of steel. Calculate the mass of a 5-meter length pole. The density of steel is 7,850 kilograms per meters cubed. Okay, so this is hollow on the inside, meaning there's nothing in the middle. Okay, so what I'm going to do is I'm going to work out the volume of the whole thing by using this equation here, the volume of a cylinder, pi r squared times L. Okay, so let's work out the whole volume there. So if I divide the diameter by 2 and then actually convert it to meters as well before squaring it, then times it by pi and then times it by the length. That's the total volume there. Then I'm going to subtract the volume of the hollow space in the middle. So inside, there's just a lot of empty volume there. I'm going to subtract that so I get the actual volume of steel there. Okay, so I'm going to figure out the internal volume there, subtract it to get the volume of the actual steel the hole is made out of. So then I can multiply by the density of the steel, and that gives me the mass of the pole, which is 17.7 kilograms. That's a sensible number. Okay, brass is an alloy of copper and zinc, and it consists of 70% by volume of copper and 30% by volume of zinc. The density of copper and zinc is given. Calculate the volume of a 5 kilogram block of brass. So if we imagine this is the 5 kilogram block of brass, we've got some parts of it as you can think of some parts as being made out of copper and some part being made out of zinc. Okay, so we're going to use this equation here. The mass equals density times volume. But the mass of the brass is equal to the mass of the copper and the zinc inside added together. Okay, so we've got the mass of brass, which is we're trying to find is 5 kilograms. The mass of copper we don't know, but we do know the density of the copper and zinc, so we can use that formula there. Now the problem is we don't know the volume of the copper inside or the volume of the zinc inside, but we do know what percentage of the total volume they are. So there's 70% and 30%. So I can write 0.7 times the total volume, which is Vt here, and 0.3 times the volume, total volume for the zinc. Okay, so now I can put the numbers in. 5 kilograms is the total mass of the brass that we're looking for. Then we've got the density of copper times 0.7, so 70% of the total volume, and adding on the mass of the zinc here, which is the density of the zinc times 30% of the total volume. I'm going to take out the total volume here out of this expression like this. So it's a common factor, so I've taken it out. So I can divide both sides by the expression that's inside the bracket there. So I get 5 divided by the whole term inside the bracket. That gives me the total volume at 5.98 times 10 to minus 4 meters cubed.